Hey everybody, I'm Michael Hall.
And I'm Robert Wolf, and you're watching Innovation Coffee, brought to you by ARM, where the coffee is hot and the innovation is hotter. In fact, in this week's episode, we're going to call it Innovation Red Bull. Innovation Red Bull. No, but
No, we're not going to do that because they're not sponsoring us, so they don't get
no sponsors. Yeah, so this week, every week, we actually do these episodes where we interview developers, folks in the ARM ecosystem all around the world. And in fact, Mike, this week we're going to be talking to Konstantinos from VectorCamp. He's the CTO and co-founder, right?
Yeah, he is, and he's been really active in our community and on our developer hub too.
Very cool. Has he submitted any learning paths?
I believe he did, but you know what? Let's let him talk about that.
Okay, that sounds great. So, Michael Hall, before we go into, I don't know why I called you by your full name there, by the way.
My full government name. Wow.
Yeah, you're full.
I'm in trouble now. It's a good thing you don't know my middle name.
Yeah. Anyways, what is your middle name? We'll talk about that later.
Get onto that on the air.
Okay. So, Mike, should we just bring the guest on now, or do you want to go back? Because last week we canceled, and also, before that I was off for I think 2 weeks. So I got a chance to watch some Innovation Coffees. Maybe you can fill me in a little bit. Do you remember anything about the episodes that we had these last couple weeks?
Yeah, so a couple weeks ago, we had on somebody from Azul, which is a company who's doing a lot of work around Java, OpenJDK, the JVM, to talk about some of the optimizations that they were doing there. Some really good insights about what goes on at the programming language level to support ARM, and specifically to support the ARM optimizations like SIMD and Neon. So some really good insights into how that was working in Java. And next week, in fact, we've got Kunal Pathak from Microsoft, who's doing the same kind of work, only in the .NET framework. So we're going to get some insights there on how that's happening. But since we seem to be on this kick about SIMD and Neon, so it's really appropriate that we've got Konstantinos from VectorCamp coming on today, because that's exactly what they're doing, and I think that is a great segue into bringing him on.
Did I do it at the right time? Wow, there we go.
Welcome,
Konstantinos.
Hello, everyone. Thank you.
Welcome.
It's a pleasure. It's very nice to be here.
Yeah. So, what we usually like to do when we welcome on our guests, I think the foremost thing that we do is ask you who you are and what do you do, right? We want to know a little bit about your background, and if you have a personal anecdote that works as well.
Okay, I can do that. So, Konstantinos Margaritis from Greece. I'm the CTO and founder of VectorCamp, and VectorCamp is relatively small, but with a quite large impact, at least lately, because we're doing something that is quite niche. We offer vectorization and optimization services. Only CMD. That's what we do, basically.
So when you say vectorization, what are you talking about specifically? Because we're not talking about like vector art or anything like that, right?
No, correct. So, every CPU, I mean, at least in the last 20 years, 25 years, it has a vector unit, a unit that executes instructions that are called CMD, which stands for single instruction, multiple data. It doesn't really make your computer go faster, but it makes your computer process more data at the same time, more data in a single cycle. And that has proven to be extremely efficient. I mean, green computing is all the rage right now, and lately with regards to efficiency and power saving. So it's really important to make sure that we benefit from the performance that our computer can give at every time. Which is sad when you see really bloated software. It makes me really sad, and I really want to make it get as much performance as I can from the computer.
So
and the CMD unit just gives you that opportunity.
So I'm looking at that. I kind of want to understand the services here that you're offering at VectorCamp. Maybe we can talk a little bit about that, because I'm seeing Intel, AMD, ARM, IBM Power PC or IBM Power. You have IBM S390.
Yes.
So maybe you could walk us through what exactly you're doing to make this.
Okay. Let's take a small example.
Okay.
So let's say that your you are a company that specializes in video codecs, right? And video codecs have a lot of linear algebra math. That is, they take an array and they want to take the inverse of that matrix. Sorry, not an array. They want to take the
Mhm.
inverse of that matrix, and then they want to multiply that with a vector or with a constant and sort of that stuff. If you have a scalar code, your typical reference C loop that you're going to find in a book, that means you are going to execute as many instructions as the operations are involved. So if you have 30 multiplications, you're going to execute 30 instructions of multiply, etc. But if you have a CMD unit, you can group those instructions together. And though in the data, you can group them in depends on the data type, on the width. You can group them in groups of 4 or 8, 16, depending on the what your hardware can support. So you have like the original Altivec in PowerPC was 4 floats, same as Neon, and same as SSE for Intel. And then Intel produced, they gave the AVX2, which doubled with, and then ARM gave SVE and SVE2, which are really, it's not exactly CMD. Well, it is CMD, but it borrows a lot of the features of the early Cray vector architectures. So if you know Cray, right? You've heard the
Yeah, it's
name.
a supercomputer
Knows that.
company.
I mean, it's amazing because that kind of CPU that takes the whole of the room and
Mhm.
consumes kilowatts of power to run. You have that power right now in your cell phone. Actually, you have millions that power in your cell phone, million times, and that used the vector architecture. So the CMD and the vector architecture, they're not the same, but they shared some very similar features. Without going into too much technical detail, let's the result of that is that your software benefits from the hardware. Instead of waiting for, let's say, 10 seconds for a calculation to complete, you're waiting for one fourth of that. So 2.5 seconds. If you have more powerful instructions, you can even get an even better ratio. So 8 times, 16 times. So it's not unheard of to see, uh, I don't know, 50 times faster algorithms that run on CMD because they're
Right.
optimized.
Now, different architectures have different SIMD instructions, right? The ones that
Yes,
Intel has in their chips are different from the ones that are in ARM chips.
yes,
So
I
what
did
what led you
play around
to
with that.
start working on the ARM SIMD instructions?
Okay, so it's not a very difficult question. It came through. So let's start with I started with PowerPC and Altivec at that time.
Mhm.
At that time, it was very powerful. Uh, in with today's standards, it's not really very powerful. It's okay, but it's left behind by the competition. And then IBM took that and they advanced. They added some new features, and they doubled the width, the vector width with AVX2, and they doubled that again with AVX512. But there is a big problem with that approach. I mean, they added more instructions all the time. At the moment where you have right now, I did a measurement a few months ago, and in the intrinsics for Intel, they are about 7,000 intrinsics. So, a developer that wants to take full advantage has to know about 7,000 intrinsics, give or take. But the problem is that so you cannot remember all that. You have to.
Yeah,
I constantly have to keep reading at the reference manuals.
probably a giant book of
Yeah,
instructions.
about
And it
3,000 pages each. So it's not really optimal. And parenthesis, I might have something for that in the future, but stay tuned. I'm not going to mention anything here, but it's going to be a surprise, and it would be a pleasure to announce it here.
Oh, hey, way to go.
Yeah,
Uh,
we'll have you back on for that
yeah,
for sure.
it's going to be it's going to help developers like myself. So, but yeah,
You know,
no more on that. Yeah.
I have to say, your explanations of both of these things that you've just been talking about are top notch. I mean, as evangelists, one of the things that we have to usually do is take very technical matter, and articulate it to
Yeah.
the average folk, right? But gosh, I mean, I'm starting to really grasp this concept. For people out there who didn't understand this, grasping the concept of kind of like bundling up these operations, right, and executing on them with a kind of single cycle, right? And this
Yeah,
is
that's exactly the point. It's like, I don't know if I can use the analogy with cars, but imagine you have a very powerful car. I'm not really car literate, so I might say something stupid. But let's say that you have a car with 16 cylinders and you're constantly using one.
Yeah.
And with the CMD, you have the opportunity of using all 16 of those.
boom.
Right. So, but you have
Nice.
to be extra. Well, I wouldn't say an expert because it's not that difficult anymore. I mean, there are great tools and documentation. It's not like 20 years ago
Mhm.
where documentation was very sparse. But it's really, really important. I mean, especially with the system software, you have to really know that you're taking advantage of the software. Otherwise,
So
we're talking about wasted energy. I mean, you know that everyone is
yeah,
raging about the eco-friendly computers, and
we've got a
unless we're
question in the
using
chat.
them right now. Yes,
Sorry
really.
to interrupt, but we've got a question in the chat that I think is really going to be a good way to introduce us to vector scan. So Samuel Miller is asking, says, I looked at SVE when AWS Graviton 3 came out.
It is. It is. You're correct. It is underused right now. So I would mention about SVE. Um, so SVE, as I said, it is CMD, but it's not entirely CMD. It has a concept that it has borrowed from the Cray vectors. It is a variable vector width architecture, which means that you don't know about the vector width until the runtime, which makes up for some very interesting problems. It can really save you time when developing, but it also means that you have to take special care for SVE and SVE2 code because it's not your typical CMD. I'll give you an example. Because of the way that CMD code has been developed all over for, I don't know, since the beginning of CMD, it depended on aligned buffers. So aligned means that you have to have your bytes at an address which is aligned on 16 bytes. Otherwise, you're going to get a crash or underperforming code, or you're going to get I don't know, a trap, hardware trap, or situations in general that you don't want to get into. So you cannot just run the loop from the beginning of your buffer to the end without caring for alignment. So every CMD code you're going to see has splits the data into three parts. So the beginning, the head, where you cater for the bytes until it is aligned. Then the main loop of the code, which is really does the bulk of the work using your CMD instructions, and then the tail for the remaining byte. Because if, for example, you have a CMD unit with 64 bytes, right, and you're past a buffer that is 66 bytes. Sorry, one at the beginning before it's aligned, and one at the end after the align. So you have to have a special code that takes into account the first byte, then the main loop that takes care of the 64 full bytes that are fully aligned, and you can process with just a few instructions. But then you have to use to take account the tail bytes, the single so for the cater for the single byte at the end,
So
and that
a lot
takes.
of developers, this is all much
Yes.
lower level, right, than they're used
Yeah,
to
yeah,
doing.
yeah, it's
Even
definitely
C
very low
programmers,
level.
they're used to just writing C code and compiling it for an
It is
architecture.
C, assembly, and lately, because it has become much more popular and it's going to become even more important in the future, Rust has becoming to be a very strong player in the game. I don't, it's not my prediction. I've read it somewhere else, but I suspect that in the next 5 years we're going to see a lot of software being rewritten in Rust, and a lot of performance software, security software. Uh,
I want to
no,
bring this computer
no,
up
no.
to you. Yeah. Yeah. I mean, this
Yeah,
computer, this question.
our services concern basically anyone who wants to optimize their algorithms. But I should be more uh, more explicit. We're not really doing. I mean, if you're worried about website optimization, we cannot do that. It's not C software. It's not something low level.
Hmm.
If you have a driver, or you have, let's say, an HPC application that does a lot of mathematics and a lot of computations or simulation, or I don't know, video codecs, audio codecs. We have done those. We have actually, ARM has contracted us to optimize the high bit depth video codecs. Actually, no, sorry, the high bit depth variants of the VP9 video codecs and the AV1 Libo AOM video codecs, and we saw some really nice performance improvements at the time.
So you don't want people calling you and saying like, "Hey, make my website faster."
I cannot, even if I wanted to, I cannot do that. I mean,
Yeah,
But what people could do is, they can optimize whatever is running that website. So whether it's C code in like
we
the
could, but
Nginx or in a library or even a language like Python, the Python interpreter,
that is true. That is true. And but when you have such a high level component, trying to optimize with CMD is like having, I don't know, a very old car and trying to use the jet plane fuel into it and trying to make it go faster. There are much better ways to make it go faster or be more efficient. So
so
this is the last part to make it go faster.
So
knowing where in your code to start using these SIMD instructions is, that's a very specific kind of knowledge. But this is where tools like VectorScan
Profilers.
can really help a developer, right?
Well, VectorScan, it's just a software that, like everything. So we did the same. You need, in order to understand what kind of software, what kind of parts of your code you need to optimize, you need a profiler. You need to profile your code, see exactly which functions take what kind of percentage on your CPU, and also different variants of your CPU. I mean, it might take a different percentage on a Graviton 3 than an Ampere, or an SVE2 CPU like uh, the Yixian in Alibaba Cloud, um, or a cell phone, because they are different CPUs, but all of them share the same characteristics. Well, more or less. For all of them, you need to profile your code. And when you profile your code, you know where your hotspots are, and you need to optimize those. I mean, there's no point in trying to optimize a million times a function that's going to be executed once in the startup of a program, because it doesn't have an effect.
Hmm.
But if you have a small function that is executed a billion times, and you optimize that to run, I don't know, 5% faster, this is going to have a huge impact in your code. And
oh yeah.
that's what we're doing basically.
So Konstantinos, I'm looking at the website here. I'm looking at again under the services page, and I'm seeing that you have blockchains there listed as something that you work with. Um,
Yes,
can
indeed.
I yeah, so I'm a big fan of the blockchain technology.
Yeah.
I've been in crypto for at least like I think 7 or 8 years now, and I'm curious, which blockchains have you worked with? Are you allowed to share?
Okay. I can. I mean, I can. I can give a mention to the company I used to work with. I really enjoyed what I did at the time. So that company was Fetch.ai.
Fetch? Okay.
So it's the FET token. And what I did was kind of a novel thing, again with vectorization. So the original approach that Fetch started was to have a VM running on every node on the blockchain system network, and that node would run AI code. So it would really run the models, share the models, distribute it along the network. They would try to use machine learning techniques, propagations. I'm not really familiar with all of that terminology. I might say something incorrect. But what I worked on was the vectorization backend. So I was working on the vectorizing into C++, the mathematical operations involved. So if you did, let's say, a matrix inverse, and you called the matrix inverse operation on the blockchain, and it will run on a node that supported AVX2, it would convert those instructions into AVX2 equivalents, and it would optimize the operation.
Very cool.
I don't work for that company anymore, obviously, and I understand that they have changed their goal and their methods, but the end it remains pretty much the same. It was really interesting. I have to say that. I have to admit.
Very cool. No, I mean, that's awesome. I guess, I think about it, a little bit more now that we've been talking, and there's lots of optimization that is required in the blockchain space, and there just aren't enough
Yes,
people,
yes,
working, I think, on those technologies. So I think that's really cool.
that is true, and we haven't seen anything yet. I mean, the
Yeah. Oh
future
no.
holds many surprises, and the computational needs. I mean, imagine a world that is connected in the in a blockchain network. I don't know which is going to prevail. Uh, the computational needs that of every service that's going to be running on that network. Imagine a whole society running and asking services. The computational needs are going to be enormous.
See, Mike, I told you blockchain's huge.
It
Well,
is.
we
It
share
is.
so
It
many of
is.
the same needs, right? So, like, blockchain, cryptography,
It
graphics and
is.
signal processing, machine
Yes.
learning and AI, they all kind of share the same math, right? And that's where these vector extensions really excel.
Everything is some form of it either includes statistical analysis or linear algebra or calculus or some other mathematical form. So anything that has a mathematical formula can be translated into a code, and that code can usually be optimized with CMD.
Yeah, so Mike, I'm seeing you still have a bunch of questions on the list here that I don't think we've gotten to yet.
Yeah, I kind of want to know like what the process is that you go through when you go to optimize a piece of software and you're looking for where you can introduce these specific instructions. What are some of the challenges that you face, and what's kind of like your process for finding out the best way
Uh,
to put those in?
okay. It would be good if I mention what process we followed with VectorScan in
Okay, yeah.
particular, because lately, because of some recent changes, it started to pick up a lot of interest in the industry. So VectorScan is a software. It is a fork of Hyperscan, which is from Intel, and that software does regular expressions, but in a massive scale. So imagine that you have to parse your network packets for regular expression strings, but not 5 or 6 or 10 or 50 regular expressions. Imagine that you have to check your packets for 40,000 regular expressions to check every single packet if that string matches one of those 40,000 regular expressions. That is huge. I mean, the software behind it is really amazing,
Hmm.
and there's a lot of research. And kudos to the guys who wrote the scientific paper, the original software. So the original software was Intel only. Well, the original was very much scalar, but Intel bought the company. I apologize, I forget the name of the original company. And Intel bought the software and made it Intel only. And they optimized as much as they could possibly optimize of the software. They used almost every feature that they could use with SSE instructions, AVX2, AVX512. But in the process, they made it in a manner that was not really portable. And you could not run it anywhere else. You needed an Intel CPU or an AMD CPU, but Intel architecture at any rate. So when 3 years ago, Robbie Williamson from one of you guys,
I love Robbie.
I love Robbie
Cheers
too.
to Robbie. Yeah,
Greatest.
he's one of
He's
our
one
favorites.
of my favorite persons. I
Yes.
really and yeah, I really love him. And
Yeah. As soon as you said his name, my face started to glow. I'm like, yeah.
yeah,
Oh, Robbie.
he's really a great guy. I hope he's watching. So when Robbie at one point he contacted me on LinkedIn because he we had talked about in the past about vectorization and in general, just casually. And he just gave me a question out of the blue. And can you do vectorization on ARM? Or would you be interested in doing that software? I said, of course. I mean, I love this stuff, obviously. So The original request was to port Hyperscan to ARM and then contribute back the changes back to the original project. So Hyperscan with ARM extensions. And that was required two phases. The first phase was to split from the existing code the platform specific instructions. So what the problem is, you cannot, if you try to do that and do the place fill the place with if defs everywhere, you're just complicated the source code. You're making it much more difficult for everyone to maintain, and you're putting all the specific instructions for Intel and ARM on the same file, which is going to be a hell to maintain. And the Intel guys would never accept that. I wouldn't accept that, to be honest. So what I did, I split them into entirely different files. So the ARM specific instructions would be on their own separate file. The Intel specific instructions would be on their own separate files, and developers of Hyperscan would just use let's say the generic intrinsics that were already there in the software, by the way, and use those without caring what their software would use, depending on the architecture. They would use Intel instructions on Intel, ARM instructions on ARM, etc. So that was the first patch that was left unanswered. And then after a while, I completed the port. I mean, the while was like a few weeks. I completed the port to ARM. All the tests were passing. We saw significant performance improvement, and there was no major impact on the source code. I mean, I didn't break Intel's code, let's say. Okay, and that was left unanswered for a while, and at some point there was an actual question: hey guys, do you intend to do something with this, or can you please tell us if you're going to merge or not? And there was a reply: sorry, we're not interested in supporting any other architecture than Intel. That's it, period. So we were left with no choice, really. We either have to follow Intel and maintain a side project, and let's call it Hyperscan plus the ARM patches, or after a long discussion, I mean, I remember that discussion with Robbie. We did discuss it for a long time. What were our options there? And I suggested we fork it completely to a new project, and we had to make sure that we don't use the name Hyperscan. I would say, okay, our company's name is VectorCamp. Why not just call it VectorScan?
That
And
is the beauty of open source,
it,
though, isn't
basically.
it?
That's the birth of VectorScan.
That's the birth of VectorScan.
Oh, that's cool. That's really cool.
That's cool. Yeah, and so the code was running quite well. Oral tests were passing. Because I'm a Debian developer, I uploaded it to Debian as well, and that way it propagated to Ubuntu and other people. Alpine support came even before I uploaded to Debian, and Alpine Linux supported it. Gentoo, SUSE, I think all the major Fedora, all the major architectures supported nowadays.
Nice.
And out of the blue, a few weeks ago, Intel gave us a huge present. Yeah, I mean, for us, it was, it is.
For you, it worked out for you, didn't it?
I mean,
sorry, I kind of interrupted. Go ahead and tell everybody what that present was.
Yeah, they closed source Hyperscan completely. So, yes.
So since they closed it, VectorScan became the go-to.
There is only one open source Hyperscan, let's say, compatible system.
Very cool.
And they said that from versions 4.5 onwards, you're going to have to buy it, and because it's a Intel proprietary license only. That is both a problem and a good thing for us. So the problem is that we cannot chase compatibility anymore with Intel. We would have to reverse engineer, and that is a no-go for us.
But it's really nice for every open source software developer who was using Hyperscan that you did fork it when you did, because now they can just swap their code over to start using VectorScan, right?
Well, I have to be honest. I wasn't expecting that we would have vector scan. I was expecting that okay, we're going to fork it, we're going to merge the patches, and then it's going to be a project that is going to be eventually forked to other architectures. Well, like most other projects. I mean, there's no good reason why you shouldn't be able to run it on, I don't know, any other architecture. So someone might want to run it on a MIPS router. I don't know. They could, they should. Why not? There's nothing technical that should forbid it.
So, Konstantinos, I have a question from Dara Graylish. I'm not sure if you know him, but he's from 56K Cloud, and he's watching, but he's not messaging in YouTube. He's actually messaging me on Discord in a DM. So he
Okay,
has a question for you. He's one
sure.
of our ARM ambassadors as well. He says, ask Konstantinos about extensions in CPU arc that is for like IPsec acceleration, and if people having taken it into other use cases. If people have taken this into other use cases, does that question make sense to you? Because I may
Uh,
have read it.
it might make better sense. Unfortunately, I'm not familiar with hypersec acceleration, so presumably, like many other crypto extensions, it might be possible to optimize it with CMD or SVE and SVE2. I'm not sure. I cannot say. I might make a mistake. And,
So he gives an example. He says, example, like this tokenization and hashing for crypto bank workloads. Um, that's the example he's giving.
yes, okay. Okay. So these kind of hashes usually use big integers like 256 bits integers. They use the hashes there. They perform additions there, uh, and that way you have big integer arithmetic essentially. It is possible to optimize that with CMD, and it is actually done in many software.
Okay.
So it is not trivial, and it's not really. You're not going to get, because of the nature of the problem, you're not going to get a 4-time speed improvement. You're still going to get a lot of improvement though.
Okay, cool. Well, I hope that answers your question, Dara. I have one question here for you that I think is very important. It's probably the most important question of the day. Um, what is yours or possibly VectorCamp's preferred architecture? I mean, this is kind of coming out
Yeah.
of
Nope.
coming out of that big discussion we just had about the birth of
Okay.
vector scan and all.
Well, obviously, okay. I started talking about that, but I didn't finish that. I mentioned something else. I really like ARM. I really, really like ARM because, and the reason I like it, and I mentioned that Intel had 7,000 intrinsics. The reason I like it is that it's orthogonal. It's an orthogonal architecture. I mean, people can hear about, okay, yeah, it's orthogonal. What does this mean? It means that you can predict the instruction you need, the instruction you're going to need based on your needs. So if you know the generic instruction you're going to use, let's say add W, add and widen, then, and you know your data types you're going to use, if you're going to use, I'm going to add 4 16-bit integers to 4 32-bit integers, and you know the instruction, you know you can predict all the possible variants of that instruction for all the possible data types you're going to use. And that is something that cannot be said of any other architecture. I mean, I really programmed VSX on Power, Intel, all variants, mainframes, uh, and ARM is one that I have to look at the manuals, at the ISA manuals, the least.
That's
So
beautiful.
I've heard
that's
that same thing from so many people who
yeah,
are like coming from Intel Intrinsics and learning the ARM ones. They're like, it just makes so much more sense. It's so much easier
yes.
to learn.
So it's so much easier. It's not, well, it's not dead easy, but it's. I mean, comparing having to read 3,000 pages in a manual or checking up an online resource that, and there are many, but you cannot really, you're not never sure, is this exactly the instruction I'm looking for? because there is this other variant which does the something similar. I mean, okay, wait, were there two permute functions? Oh, this works on 120-bit lanes only. Oh, but I need something that works on both lanes. What do I use that time? Stuff like that. ARM
Mhm.
does not have this kind of problem. If it works, if there is an instruction, because there's always a possibility that there's no instruction for what you want to do. But if there is an instruction, you can be sure that you can know how you're going to use it.
Very
So
nice.
Konstantinos, we are all the time improving, our instruction set architecture.
Yeah.
New ARM chips with those new instructions keep coming out. What is coming up in the near future, or maybe what are you currently working on in terms of new instructions that you're excited about?
Okay. So one of the things that have me very excited is the addition of SVE support in VectorScan. So there is some preliminary support in there that was added by, no, not by us, but by one of your guys, George Ward from ARM. And that was a proof of concept to show that it's actually possible to optimize a vector scan some engine, some particular engine, because there are many regular expression engines inside vector scan, and I mean, depending on the regular expression involved and the data involved and the kind of search involved, all those different search patterns, they are asked. Uh, they are used in different cases. And unfortunately, you cannot optimize all of the. I mean, not at the same uh, point level at least. You have to make a choice, and because of the nature of SVE, remember we said that it's not entirely CMD. You
Mhm.
don't know the width of the vector at runtime, which at compile time. You know it only at runtime because there are SVE platforms with 256 bits, with 128 bits, or 512 or 1024 bits. That means you cannot use a container like most other C++ classes that are used, excuse me, that are using CMD classes to offload and abstract the CMD code. They're using these containers. Because of that limitation, you cannot use a container. But I found there is something I'm working on, but I haven't finished it yet. So I'd rather not say if it works because I don't know if it works it, but I have a good impression. I have a good insight that it's going to work. Excuse me.
So, can I bring another question from Dara into?
Of course.
Okay, so
All right,
Dara.
why are you not in the YouTube chat? Come on, man.
No, he's cooking right now. He's listening to us.
Oh,
He's watching us on whatever his monitor or his television. And I guess he's typing on his phone maybe. Anyways, from Dara, this is another question. He says, what can the community do better to bring visibility down into the silicon manufacturers where we miss the tooling, example, libraries, to make the best use of such accelerated instructions? What advice do you have here?
Right. Okay. So this is an advice for the companies that for a company like ARM or some other company that develops the IP. Typically what you do is you think about the instruction. Oh, this could be cool to have, but and then you add the instruction, and only after you have the first FPGAs. Well, okay, you probably have the software simulators as well, but these are very slow. But only after you have the software running on a bare metal or an FPGA, only at that point can you know if your instruction was good, if your suggestion was good. So it might be great if there was a way for people to suggest to ARM, let's say, hey, ARM, I have this use case. I have this expression that is not, I don't know, it's not implemented currently in a single instruction or in a pair of instructions.
mhm.
Wouldn't it be cool to have something like that helps this operation? So your guys would take this operation, they would map it in an instruction, and they would uh, preferably have a proof of concept that demonstrates that and can demonstrate the goal the performance gain that you would get from replacing the generic instructions produced by the compiler by a single assembly instruction. I'm pretty sure that you already do that in some extent, but it would be nice if you could allow people to, I don't know, suggest. I don't know. I guess there are many IP problems involved, and it's not really your typical. I mean, CPU architecture is not your typical open source project where you
No. It's
Yeah.
also it would be really slow to get
Yes,
that out. Like by the time, but the time between somebody saying, "Hey, this kind of instruction would be great," and them having hardware that actually has implemented that is going to
yeah,
be several years, just because of the
it
manufacturing
is.
cost.
But I had that. I have to say that I had that epiphany with when coding, when optimizing for libpx and libaum. So in these video codecs, and pretty much every audio and video codec, there is the DCT algorithms, discrete cosine transformations, and those use the so-called butterfly instructions, one coefficient, two coefficient by butterfly instructions. Currently, the approach that is given even on Neon is not ideal. And what I mean by that, I mean, yes, of course, they're faster than Scalar, much faster. No question there, no discussion there. But you have, depending on the precision that is required, you have a fast version of the butterfly instruction, then you have a slow version or accurate version, then you have an increased precision for high bit depth, and then you have the same thing for the same thing for the instructions that are for two coefficients. So that I don't remember how many those, but those were I don't know 10 or 12 functions that were doing exactly the same thing, but they were there because the original, the existing VQMLH, I don't remember its exact name, instruction that is already there in Neon, it doesn't support the full precision that is required by these audio codecs.
Mm-hmm.
So, and because I'm involved in some other projects, and I wrote some replacement instructions that can replace those 20 instructions in assembly with 3. So
Wow.
I would really love to find a way to submit that to ARM, and I don't care if I get paid for that. Even
No,
even the
that's
idea that I get.
Well,
no,
you know
I did
Robbie,
send an email
so
to Robbie about this, by the way.
yeah.
no, that's really cool. I mean,
Yeah.
and this brings up another. I'm curious at this point now. Have you heard of the ARM Developer Program? Are you familiar with the ARM
I
Developer
am.
Program?
I already submitted. In
You
fact,
did. You
yes,
submitted to become an ambassador. Did you submit to become an ambassador?
I yes, it. I was requested to become ambassador. I submitted my application. I'm waiting for.
Awesome. Yeah, we
So
close.
yeah.
The applications close tomorrow on the 8th. And
I
so
already submitted before that.
that's
So
great. Yeah. So as long as you submitted, we'll make sure to give your application a review there. Would love to have you on. Dara is literally messaging me. He's like, don't forget to invite him to the ambassador program. It expires.
I already
expires.
am. Thank you. Thank you for
Yeah.
that.
No, that's great. And referring to this last question that he just asked.
Gemma Paris, basically, by the way. She
Oh,
invited.
you know Gemma Paris.
Yes,
Great.
Gemma.
She's
Yes.
Oh,
she's
Yeah.
on our team. So
Gemma Paris is the one that invited us to write the learning paths.
I was
oh,
going
that's
to ask
awesome.
about that. I remembered that I think you submitted one. What learning path did you
Two
submit?
actually,
Should we
two of
pull that
them
up too, by the way,
are
Gabe?
already
His
the
learning path?
memory latency and the restrict keyword in C.
Memory latency.
Yeah,
We're
I'm
gonna pull that
writing.
learning path up and we're gonna share it here.
Great, thanks. And I'm writing. I'm currently finishing. I should have delivered already. I apologize for that.
Oh, I'm in the
But
same boat. I've got one that's like almost finished. I just need a couple hours to finish it up and send
yeah,
it.
I intend to finish it today and submit it tomorrow. So the next one is about integer float conversion. So we have an integer to float conversion. You have an expression, and you're using a float, but your compiler implicitly converts from one to other. By implicitly, it adds an instruction. You're not aware of that fact, but it will add an instruction that will do the conversion. That instruction costs CPU cycles. If it's just once in the beginning of your program, it's okay, you don't care. But if it's in a critical loop, you lose performance that way. And
Yeah.
imagine having a huge expression with I don't know, hundreds of constants, and you have to convert each and every one of those to floating point or to integer. Uh, that's going to have a huge impact in your performance.
So, Konstantinos, you're clearly an expert in this. You really know what you're talking about and how to
Number one
optimize
expert.
the
No,
software.
no. I
So,
know that's the thing. When you know a few things about these concepts, and then you meet someone and you're absolutely blown away, or say, okay, this guy is a genius, he's a guru. And I have met quite a few of those, and
You
so I
you
know that.
sound like a guru to me. So I want to talk about VectorCamp because if somebody has software that they want to optimize and they don't have that expertise and they just want to hire somebody to do it, how can they reach out to VectorCamp? Like what do you
Okay,
offer them?
they can contact us. They can contact at info.vectorcamp, sorry, info@vectorcamp.gr, and they can request that we check their code. I mean, if it's open source, it's the easiest way because we can just go to GitHub or a Git repository, check the code, see if there is an actual opportunity, because not every software can be optimized with CMD, and in some cases, it is not really needed at all. I mean, let me give you an example. If you have an SQL database and you need to sort the elements, you have a billion elements, you need to sort them. You don't need CMD for that. You need a good sorting algorithm. So, but even changing the sorting algorithm can give you an order of magnitude performance change. Uh, so
And that's a lot.
that's a lot. That's a
Yeah.
lot. It's even fixing problems like IO. One of the projects I did in the past was for the search engine. I'm not going to mention that. And they wanted initially to optimize their search engine, well, basically the backend database, and they used the flat file database. And they wanted to use CMD. I said, your problem is not CMD related, it's IO related because you save everything to disk. And what I did, I compressed everything because their disk was slow. Were not using uh, terabytes and hundreds of terabytes of data. They were not using fast NVMEs to store those hundreds of terabytes. They were using spinning Rust, old disks, right? But
Oh,
lots of them. I mean, enormous amounts of data. So it is faster to load a compressed huge file that's of a few terabytes. It is faster to load that compressed, uncompress it in memory, and then just process it. CMD is not going to do anything in that case for you. I mean, it's a useless tool
so can you give
because
us the
your
opposite example? What kinds of software are ideal candidates for sim?
the ideal candidates are the HPC, high performance computing, like simulations, Monte Carlo simulations, machine learning, deep learning, all the AI rage that's going on. That is ideal for CMD. CMD, and also don't forget that all of these AI, uh, 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 it's fashionable, it's trendy right now. AI is trendy, so all that led to the advances of the matrix extensions. I mean, previously we had the vector extensions. Now we have the matrix extensions. ARM has the SME, which is about to be released. Well, about to be released in the next architecture revision.
Mhm.
Scalar matrix extensions. Intel has their AMX, and Power has their MMA. All of them do more or less similar things, not exactly the same things. All of them, they have the way to process huge, well, not very huge matrices, but they have the instructions to do operations on a matrix directly without splitting them into separate instructions, but using vector instructions. It's still faster to than doing scalar, but it's much simpler. I mean, instead of rolling out your code with dozens of vector instructions to do a matrix multiplication, you just call one or a couple.
Mhm.
So yeah, it's going to have. We're going to see that to have even more impact in the future. And someone might say, okay, why not use a GPU for that? And we are first, but GPUs are not the solution. I mean, there are very specific limits with regards to using GPU. For a start, memory. I mean, I can buy a server right now. Actually, I did an Ampere dual socket, and I can just put 2 terabytes of RAM in it. You can never do that on a GPU. Well, you can if you want to spend €1,000,000.
Yeah, crazy.
Yeah.
Yeah.
The more you can do on the same, in the same CPU core, the better, right? You're not having to pass that data
Exactly.
between CPU and
Exactly.
the GPU and back again.
So because the CPUs are much more, they're much more scalable and they're much more versatile in what they can do. You can put a lot more instructions in them, and you can take advantage of things like you can still use a GPU. I mean, no doubt, you can still have a CPU that takes the bulk of the computation, or does the orchestration of the computation, and you localize the data, which is already being done, by the way, into separate GPUs. But the GPUs will never be able to handle terabytes of data. And that's what you see in today's data centers. You see data center servers with 2 terabytes is the minimum of RAM, and we're talking RAM, not disk. That's I mean, for people that are using desktop, 2 terabytes of RAM is crazy. I mean, come on, guys, 2 terabytes is my disk. And
yeah, I'm trying to think of how many. I think I have 64 gigs of RAM on my like home desktop.
Yeah, so you're still 2 orders of magnitude away.
Yeah.
Yes.
Yeah, big time. So Konstantinos, I hate to do this because I'm not going to lie. You are I've had over 100 guests on this show, and you are probably one of my top 5 in terms of the fun that I've had.
I'm very honored.
Yeah, no, I mean, just the way you explain things has just been truly, truly awesome. But we do have to call it. It's getting towards the top of the hour. So I just wanted to, conscious of your time, conscious of our viewers' time here. Well, so Michael, is there a last question you have for him, or do we go into the shameless plug time? What would you like to do?
Oh, he's answered all of my questions and more. So I think it's time to go into shameless plugs.
Okay, great. So Konstantinos, this is kind of your opportunity. If there's, you want to plug your website, you want to plug, your services. Is there anything you'd like to kind of tell any viewers that are watching now or on demand later?
There is, I just submitted a talk for FOSDEM. If you are aware of FOSDEM, that's going to be for VectorCamp, and I'm going to be explaining the software in detail. And it's not. I haven't got a reply yet from FOSDEM, but it's submitted. I mean, we're expecting the results next week, apparently.
Okay, yeah. So I want to share this.
Good luck with that.
Yeah, I hope you get it. And you know what? We're waiting on some news. Yeah, I just shared the link to FOSDEM 2024. It's in Brussels on February 3rd and February 4th.
It's one of the biggest open source software events. It's one of my favorites.
We're waiting to find out if Ampere got a room there. And if they got a room, we might show up. So that
I would be glad to meet you guys there.
Yeah. Oh, definitely. Yeah, it would be a lot of fun.
That would be great.
Yeah. So it looks like ARM is sponsoring it. Even I didn't even know that. Looks like
I think Alex went last year.
Who?
I think Alex went last year to FOSDEM.
Alex Mercer?
Yeah, I think so.
Oh, interesting. Okay. Yeah. So maybe we will see you there, and that would be a lot of fun. Other than that, just want to thank you. Konstantinos, this has been great.
Thank you. It was a pleasure, an honor. And I mean, if you let me, I can talk about this stuff for hours.
Oh, I would listen.
We're going to have you back on it again for sure. Especially you hinted at the start of the show that you had something that you're excited to talk about but can't yet.
Yeah, it's a promise. When I'm going to make it live, I'm going to tell it in this place first.
Oh, that's great. Well, that's awesome.
That would be awesome.
So Konstantinos, then on behalf of ARM, on behalf of us here, Michael and myself, thank you so much for joining us. We'd love to have you. We'd love to have you on a again. Michael, before we close out here, or before I close this out, can you maybe plug next week's episode real quick?
Yeah. So if you've enjoyed this discussion and you're curious about implementations of SIMD and Neon and SVE, join us next week, because we do have Kunal from Microsoft, who's going to be talking to us about doing exactly that in the .NET Core libraries and how they've implemented that. And I've looked at it a little bit, and it's really interesting, the approach they've taken. So that's going to be a really good discussion, really technical. So if you've enjoyed this, you will certainly enjoy that one.
Awesome. Mike, thank you. All right. So I'm going to close this out, everyone. I hope you all have a wonderful rest of your day, a wonderful rest of your week. I want to thank once again Konstantinos Margaritis for joining us from VectorCamp, CTO and founder. Make sure you go check out vectorcamp.gr. Great website, great services, great stuff going on over there. And if you have any questions, please go ahead, check the description below. We'll make sure that we include everything that we've talked about there in terms of websites, in terms of URLs, of course, any other stuff that we talked about there. Y'all have a wonderful rest of your day. We'll see you next week. Innovation Coffee live every single Thursday. Button. Oh, yeah. Do we got to remind people about that?
You got to hit that like and subscribe button. Subscribe so you don't miss future episodes. Like it so that more people get to see us.
Yes. All right. And thank you so much. Y'all have a wonderful, wonderful day. All right. Take care.
Thank you, guys.
Bye. Bye, Konstantinos.
Thank you.